Hello everyone, I'm Teacher Michelle and welcome to another episode of Unang Math. This is episode 50 and for this episode, our lesson is about finding the least common multiple or LCM of numbers. This episode is divided into two parts. In the first part, I will discuss the property of LCM. We already studied LCM in episode 3, but we need to repeat the property of LCM because this is important. In the second part of this episode, we will find the LCM of numbers using two methods. Actually, there's similarity and difference between finding the LCM of numbers to that of GCF of numbers. So you need to focus while I discuss so you'll be able to point the similarity and difference. Let's start with the property of LCM. LCM stands for least common multiple. When we say multiple, this is a number times 1, times 2, times 3, and so on and so forth. To find the LCM of numbers, first, we have to know the numbers common multiples. When we say common multiples, these are multiples that are common to numbers. To find the common multiples of numbers, we have to know each number's multiples. Let's give an example. What are the multiples of 2 and 3? Let's start with multiples of 2. So 2 times 1 is 2, times 2 is 4, next is 6, 8, 10, 12, and so on and so forth. How about multiples of 3? So 3 times 1 is 3, times 2 is 6, 9, 12, 15, and so on and so forth. Remember, multiples of a number are endless or infinite. Among these multiples of 2 and 3, what are common multiples? Okay, let's check. 6 is a common multiple of 2 and 3. What else? 12 is also a common multiple of 2 and 3. And among these common multiples, what number is the smallest? 6 is the smallest, so 6 is the least common multiple or LCM of 2 and 3. From the word least, it means this is the smallest common multiple of numbers. So what is the property of LCM? Property of LCM states that the common multiples of two or more natural numbers are all multiples of their LCM. Let's go back to our example. Okay, LCM of 2 and 3 is 6. According to the property of LCM, the common multiples of two or more natural numbers are all multiples of their LCM. Let's get 6 multiples. 6 times 1 is 6, times 2 is 12. Next is 18. Okay, 24, 30, 36, and so on and so forth. It means these numbers are all common multiples of these numbers. Property of LCM is very important because in exams or in tests, even if they didn't give the numbers, as long as we know the LCM, then we can find the common multiples of numbers. Let's give another example. The LCM of two natural numbers, A and B, is 24. Which of the following or which of the common multiples of A and B is closest to 100? Okay, we actually don't know these numbers, A and B, but we know that the LCM of A and B is 24. So using the property of LCM, we can know these numbers' common multiples. Okay, let's get 24's multiples. So 24 times 1 is 24, times 2 is 48, okay, times 3 is 72, next is 96, 120, and so on and so forth. The question is, which of the common multiples of A and B is closest to 100? 120 is more than 100. Closest to 100 is 96. So our answer is C, 96. We are now in the second part of this episode, and this time I will discuss the different ways on how to find the LCM of numbers. There are two ways on how to find the LCM of numbers. We can use division method or prime factorization method. Let's start with division method. To use division method, we will follow these three steps. Let's give an example. Let's find the LCM of 12 and 30 using division method. First, we need to divide each number by the common factor other than 1. 12 and 30 common factor can be 2. So 12 divided by 2 is 6. 30 divided by 2 is 15. Second step, continue dividing until the quotient has no common factor other than 1. 6 and 15 has common factor 3. So let's continue dividing. 6 divided by 3, 2. 15 divided by 3, 5. This time, 2 and 5 have no more common factor other than 1. Third step, let's multiply all the common factors and quotients together. So 2 times 3 times 2 times 5. And this is equal to 60. So 60 is the LCM of 12 and 30. And that is using division method. Let's move on to the second way. Okay, this time we will use prime factorization method to find the LCM of numbers. To use prime factorization, we will follow these three steps. Let's give an example. Let's use the same numbers 12 and 30, but this time I will show how to find the LCM of 12 and 30 using prime factorization method. First step, we need to factorize each number into its prime factors. It means we need to get 12 and 30's prime factorization. Let's start with 12. 12 is 4 times 3, and 4 is 2 squared. So 12's prime factorization is 2 squared times 3. How about 30? 30 is 6 times 5, and 6 is 2 times 3. So 30's prime factorization is 2 times 3 times 5. Second step, among powers with the same base, choose the one with the same or greater exponent. If different numbers, we need to choose the higher number. To do this, we need to write the prime factorization of these numbers by aligning those with the same base. 2 squared and 2 have the same base 2, and these are aligned. 3 and 3, same numbers. These are also aligned. Okay, how about if a number doesn't have a number above or below it? A number that doesn't have a number above or below it, it means the number here is 1. So this is times 1. Because when we multiply 1 by any number, the answer is the number. So it's not necessary to write 1 here. But for you to see the process, we will write 1 here. Okay, among powers with the same base, choose the one with the same or greater exponent. Among 2 squared and 2, 2 squared is greater. So let's choose 2 squared. 3 and 3, same numbers. So we will just get or copy the same number. Okay, how about 1 and 5? These numbers are different numbers. If different numbers, we need to choose the higher number. 5 is higher than 1, so we need to choose 5. Okay, why do we need to choose the higher number? Okay, what is 2 squared? Or 2 squared is 4. What is 4's multiples? We have 4, 8, okay, 12, 16, and so on and so forth. Okay, how about 2's multiples? We have 2, 4, 6, 8, and so on and so forth. 4 is a common multiple of 2 squared and 2. 8 is also a common multiple of 2 squared and 2. 2 is not a common multiple of 2 squared and 2. Okay, that's why we need to choose the higher number. If same numbers, then we just need to copy the same number. Okay, here, 1 and 5. Higher is 5. So why did we choose 5? Okay, what are the multiples of 1? We have 1, 2, 3, 4, 5, and so on and so forth. How about multiples of 5? We have 5, 10, 15, and so on and so forth. 5 is a common multiple of 1 and 5. 1 is not a common multiple of 1 and 5. So we need to choose the higher number, and that is 5. Before, if we are looking for the GCF of numbers, among the numbers with the same base, we need to choose the smaller number. That is if we are looking for GCF. Among 2 squared and 2, smaller is 2. So we need to choose 2. If same numbers, then we just need to copy the same number. Okay, here, 1 and 5, 1 is smaller. So we will choose 1. 2 times 3 times 1. Since 1 or since when you multiply 1 by any number, the answer is the number. So no need to write 1 here. Okay, but if we are looking for LCM, we need to choose the higher number. Okay, don't be confused. Your clue here is multiples are increasing. Factors are decreasing. So if we are looking for LCM, choose the higher number. And if we are looking for GCF, choose the smaller number. Okay, let's proceed to the third step. Multiply all the numbers obtained in number 2. So we have 2 squared or 4 times 3 times 5, and this is equal to 60. So 60 is the LCM of 12 and 30, and that is using prime factorization method. Okay, let's have another example. Okay, this time let's find the LCM of 18, 21, 36. And we will use prime factorization method. So first, we need to find 18, okay, 21, and 36 prime factorization. Okay, let's start with 18. 18 is 2 times 9. 9 is 3 squared. So 18's prime factorization is 2 times 3 squared. How about 21? 21's prime factorization is 3 times 7. How about 36? Okay, 36 divided by 2, 18. 18 divided by 2, 9. 9 divided by 3 is 3. So 36 prime factorization is 2 squared, okay, times 3 squared. So we will not be confused. Again, if there's no number above or below the number, it means the number is 1. So 1 times 3 times 7. Okay, let's write 1 here also. Here is also times 1. Okay, now we will choose the greater or the greatest number. 2, 1, and 2 raised to the power of 2. 2 raised to the power of 2 or 2 squared is the largest number. 3 squared, 3, and 3 squared. So this is 3 squared. And here is 7. Let's multiply these numbers together. 4 times 9 times 7. Okay, this is equal to 252. And 252 is the LCM of these three numbers. Okay, now we are ready to answer the following problems. Let's have the first one. Which of the following is not a common multiple of the numbers 2 times 3 squared times 2 squared times 5? First, let's get the two numbers. So 2, okay, times 3 squared and 2 squared times 5. So let's move 5 here. So times 5. To find these numbers common multiples, first we have to find this number's LCM. So we will not be confused. The numbers without the space here, we need to write 1 or we will write 1. 2 and 2 squared, the higher one or the greater number is 2 squared. So choose 2 squared. Okay, how about here? 3 squared. Here is 5. So the LCM of these two numbers is 2 squared times 3 squared times 5. This question is asking which is not common multiple of these two numbers. Okay, remember, multiples are increasing. And the LCM, this is the minimum multiples of these numbers. Okay, let's have the first one. 2 squared times 3 squared times 5. This is exactly the multiple or the least common multiple. So it means A is a common multiple of these two numbers. Let's move to letter C first. 2 squared times 3 raised to the power of 3 times 5. Our LCM is 2 squared times 3 squared times 5. But this is 3 raised to the power of 3. So it means we will multiply this by 3. Okay, remember, multiples are numbers times 1, 2, 3, and so on and so forth. So C is a common multiple of these two numbers. Let's have letter D. We have 2 squared times 3 squared times 5 squared. So LCM is 2 squared times 3 squared times 5. But this is 5 squared. So it means we need to multiply this by 5. So D is also a common multiple of these two numbers. How about E? 2 raised to the power of 3 times 3 raised to the power of 3 times 5. LCM is 2 squared times 3 raised to the power of 2 or 3 squared times 5. But this is, or the exponent is 3. Here is also 3. So it means we need to multiply this by 2 and multiply this by 3. So E is also a common multiple of these two numbers. Okay, now let's go to letter B. This is 2 raised to the power of 3. Okay, times 3 times 5. If you are going to take a look at this, 3 squared, this is the LCM, and then option B, this one is 3. So from 3 squared, it became 3. So it means letter B is not a common multiple of these two numbers because remember, multiples are increasing, not decreasing. Okay, let's have the second problem. Among the natural numbers less than 1,000, how many are common multiples of numbers 36, 48, and 72? So this problem is asking for the common multiples of these three numbers that is less than 1,000. So first, we need to find 36, 48, and 72's LCM. Okay, we will use prime factorization to find this number's LCM. So first, we need to get each number's prime factorization. So 36 is 4 times 9. And 4 is 2 squared. 9 is 3 squared. So 2 squared times 3 squared. This is the prime factorization of 36. How about 48? Okay, 48 divided by 2 is 24. This is 2, 12, 2, 6, 2, 3. Okay, the prime factorization of 48 is, we have 2 raised to the power of 4 times 3. Okay, now let's get 72's prime factorization. Okay, 72 is 8 times 9. And 8 is 2 times 4. 4 is 2 squared. So this is 2 raised to the power of 3 times 3 squared. So that's the prime factorization of 72. Okay, now, among these numbers with the same base, we need to choose the higher or the highest number. Okay, the highest number is 2 raised to the power of 4. Okay, how about here? 3 squared. We need to multiply these numbers together. 2 raised to the power of 4 times 3 squared. This is equal to 144. So 144 is the LCM of these three numbers. Okay, now we know the LCM. We can now know the common multiples of these three numbers. We just need to get the multiples of this 144, the LCM. So what are the multiples? We have 144. Next is 288. Okay, 144 times 3, 12, 3. So this is 432. Okay, 432 or 144 times 4. So this is 576. Okay, next, 576 plus 144. This is 10, 8, 12, 720. Okay, still can be 720 plus 144. This is 864. 864 plus 144, it's more than 1,000 already. The question is less than 1,000. So how many are common multiples of these numbers that are less than 1,000? Okay, so we have 6 common multiples, and these are these multiples. Okay, let's have the last problem. The GCF of the numbers 2 raised to the power of A times 3 squared times C and 2 raised to the power of 4 times 3 raised to the power of B times 7 is 2 squared times 3 squared. And LCM is 2 raised to the power of 4 times 3 raised to the power of 3 times 5 times 7. What is the value of A plus B plus C? Okay, let's get the two numbers. We have 2 raised to the power of A times 3 squared, okay, times C. And then another one is 2, okay, raised to the power of 4, okay, times 3 raised to the power of B, okay, times 7. Okay, we are looking for the value of A, B, and C. So A, B, and C. Okay, in the given problem, the GCF of these two numbers is, okay, GCF is 2 squared times 3 squared. And the LCM is 2 raised to the power of 4, okay, times 3 raised to the power of 3, okay, times 5 times 7. Okay, remember, if we are looking for the GCF among the numbers with the same base, we need to choose the smaller number. So this is 2 raised to the power of A, this is 2 raised to the power of 4, and the GCF is 2 raised to the power of 2 or 2 squared. It means A is equal to 2 because 2 squared is less than 2 raised to the power of 4. Okay, next, how about B, this number? Okay, the LCM here among 3 raised to the power of 2 and 3 raised to the power of B, our LCM here is 3 raised to the power of 3. So it means B is 3 because 3 raised to the power of 3 is higher than 3 squared. Okay, next, how about C? Okay, so the empty space here means 1. So this is times 1, this is also times 1. Okay, C here is, if we're looking at the LCM, the number here is 5. So it means C here is 5 because 5 is higher than 1. So C is 5. So A plus B plus C. So we have 2 plus 3 plus 5. So this is equal to 10.